Hey guys, welcome to your next video on Arithmetic Series Part 1. Our learning target again is I can find the sum of a finite arithmetic series using the formula. We're going to kind of pick up where we left off yesterday. So here we go. So this example looks much like the homework that you guys started yesterday. It says to find the sum of each finite arithmetic series, and we're going to start by looking at the formula. So let's substitute the things that we know into the formula. I know that A1 is 5. I know that AN, my last term, is 95. But I don't know how many numbers we are adding up. So in order to find how many numbers we're adding up, we're going to go back to the arithmetic sequence formula. So substituting into the arithmetic sequence formula, we know that our AN is 95. We know that A1, our first term, is 5. We don't know how many terms there are, so we're trying to solve for N. And the common difference here, let's look. 5 to 11, 11 to 17. What is the difference? Well, 17 minus 11 is 6, 11 minus 5 is 6, so we have a common difference of 6. And now we're just going to solve. So I'm going to distribute the 6 back, so bring down the 5, plus 6n, and 6 times negative 1 is negative 6. I'll put my 6n in the front and combine the like terms, 5 minus 6, to get negative 1. Then add 1 to both sides because we want to get the n term isolated. 95 plus 1 is 96. And then we're going to divide both sides by 6. So n is 16. So that means we're adding up 16 terms. So this S is going to represent the sum of 16 numbers. So 16 is n. We divide that by 2, and we get 8. And 95 plus 5 is 100. And might not even need a calculator here. 8 times 100 is 800. So the sum of the 16 terms of this arithmetic series is 800. This one's also really similar to the homework that you began yesterday. It's really similar to the previous problem. I would like for you to pause the video now and take a few moments to try this on your own, and then we'll play the video back to see if you got it correct. Pause now. So I found when I went to my arithmetic series formula that I did not know the number of terms. So I needed to go to the arithmetic sequence formula to find the number of terms. So I did that here. And I'm trying to solve for n. 4 was the first term, 99 was the last term, 5 was the common difference. I distributed the 5 back, and I got that 5n minus 5. Brought the 5n down, 4 minus 5 gave me negative 1. Adding 1 to both sides, I get 100 is equal to 5n. Then dividing both sides by 5, I get n is equal to 20. So now I know 20 is the number of terms that I am finding the sum of. So S20 is going to equal 10, 20 divided by 2 is 10, times 103, which is 1030. So the sum of the 20 numbers in the arithmetic series that starts with 4 and ends with 99 is 1030. This question it changes it a little bit. It says, what is the sum of the even integers from 2 to 100? First of all, you got to know what it means to be even, and secondly, what's it mean to be an integer? Well, we talked yesterday about what it means to be an integer. An integer is a number like you would find on a number line that does not have a decimal or a fractional part. An even integer would be numbers like 2, 4, 6, 8, 10, 12. So if we are looking for the sum of the even integers, I can express that as the following series. 2 plus 4 plus 6 plus 8 plus, we're supposed to add all the way up to the number 100. So it's pretty easy to identify. That A1 is 2 and AN is 100. So let's go to our formula. N over 2 times A1 plus AN. A1 is 2, AN is 100. We have to identify how many numbers we're adding up. In order to do that, we may go to the arithmetic sequence formula. AN equals A1 plus N minus 1 times D. A1 is 2. The number of terms that we're adding up is what we are trying to find. The common difference here is 2, and the number we're stopping with is the number 100. So we'll distribute now. 2 times n is 2n, and 2 times negative 1 is negative 2. The 2's actually cancel out. 2 minus 2 cancels out. And we divide each term by 2, we get 50. So that's 50 numbers that we're adding up. Now, are we surprised that this is 50 numbers? Or could we have reasoned that out? The even integers from 2 to 100 would be 50 numbers that we're adding up. So, 50 divided by 2, that's 25. 2 plus 100 is 102. So we're going to multiply now 25 times 102 to find that the sum of those 50 even integers from 2 to 100 is 2,550. Okay, today we're also going to look at how we can answer a reading problem that involves arithmetic series or arithmetic sequences. So, a company pays a $10,000 bonus to their salespeople at the end of their first 50 weeks if they make 10 sales in their first week and then improve their sales numbers by 2 each week thereafter. One salesperson qualified for the bonus with the minimum possible number of sales. How many sales did the salesperson make in week 50? So, the first question says, how many sales did the salesperson make in week 50? If we're talking about in week 50, that is talking about a 50. Okay, so the arithmetic sequence formula says A1 plus N minus 1 times D. Well, A1 here, in the first week, they make 10 sales. And we want to know how many sales they would make in week 50. And the common difference is that they're improving their sales numbers by 2 each week. So this will enable us to find out how many sales they would have made in week 50. So I got 108, so that means in week 50, the salesperson would have had to have made 108 sales. The second part of the question says, in all 50 weeks. That means how many total sales would the salesperson have had to make in all 50 weeks? So that's talking about a sum. So we're going to go to our arithmetic series formula, N over 2 times A1 plus AN. Well, we're talking about the sum of 50 weeks of sales. So N is 50, where the first week they sell 10, and in the 50th week they sell 108. So we've got all the information now that we need. 50 divided by 2 is 25, and 10 plus 108 is 118. So we're just going to multiply 25 times 118, and we get 2,950. So if this salesperson in those first 50 weeks sells 2,950 of whatever product this is, they'll qualify for that $10,000 bonus. Do you think that they are having a lot of salespeople that are getting this bonus? I don't know. So last, I want to remind you that our learning target for this lesson was I can find the sum of an arithmetic series using the formula. Hopefully this video has helped you to do that, and good luck on your assignment.